tutorial video for SeeSAR version 13 codename Midas, a major update that brings exciting new enhancements to our computer-aided drug discovery software. We're thrilled to have you here today as we explore the latest features and improvements in SeeSAR. In this video, we'll delve into the golden themes that make SeeSAR 13 Midas shine. We'll explore MedChemesis, the inspiration behind the codename, as well as improved protein surface visualizations, a wealth of scientific and algorithmic advancements, and enhanced usability features. Please do remember that this video is segmented into chapters which can be easily accessed from the timeline tracker below or from the chapters view. While some of these changes we'll discuss may not be immediately visible to you, they do play a pivotal role in ensuring the stability, performance, and future-proofness of SeeSAR. So without further ado, let's dive in and discover the golden touch of SeeSAR 13 Midas. This major update is a special one for more than one reason. But most of all, this version brings in a variety of architectural changes under the hood that improves not only the experience for the user, but also the maintainability of the software. The first significant architectural change is to do with the underlying 3D rendering machinery in SeeSAR. This 3D rendering pipeline in SeeSAR has undergone a foundational overhaul, adopting a modernized platform-independent architecture. This enhancement ensures improved performance and a smoother user experience. Additionally, SeeSAR's underlying user interface framework has also been upgraded from Qt version 5 to Qt version 6. While this brings enhanced capabilities, it also means that some older Linux versions are no longer supported. The good news is that we have identified which versions work and which versions don't, so all you need to do is to decide on making the necessary operating system changes if needed. On screen now, you would see a list of Linux distributions that are both supported and not supported by SeeSAR for your reference. All users with server licenses must update to the latest FlexLM 11.19.12 license package. As a general note to conclude this segment, we can say with certainty that architectural changes take time, sometimes a lot of time to build. However, by investing in these architectural improvements, we simply emphasize on our commitment to delivering cutting-edge, future-proof software solutions for computer-aided drug discovery. If you're migrating to SeeSAR 13 with projects created in earlier versions of SeeSAR, we have an important bit of information for you. Due to major improvements in the molecule handling, chemistry, and interaction models, all scores within your older projects will be reset. However, we provide you the opportunity to save a copy of your older projects, ensuring a smooth transition to the enhanced capabilities of SeeSAR version 13. Now, with most of the housekeeping out of our way, let's dive into the functional improvements SeeSAR 13 brings to the table. Introducing MedChemesis. One of the biggest functional highlights of SeeSAR 13 is MedChemesis, a game-changing capability that takes center stage in this release. In medicinal chemistry, ligand analogs refer to molecules that are structurally similar to a target ligand or a drug. These analogs are designed to interact with the same biological target or receptor as the original ligand, often with the aim of improving its pharmacological properties. Ligand analogs are crucial in the drug discovery process as they help scientists understand the structure-activity relationships and optimize the binding affinity, selectivity, potency, and other properties of the ligand. By modifying specific regions of the ligand, such as functional groups or substituents, researchers can explore how these changes affect the binding interactions and the biological activity. In SeeSAR 13, the MedChemesis feature allows users to generate high-quality ligand analogs directly within the binding site, providing a powerful tool for exploring structure-activity relationships and accelerating the drug discovery process. MedChemesis creates a series of 3D analogs of the ligand in the binding site, applying up to 290 medicinal chemistry-inspired transformations triggered by one click on all the molecules added to the Inspirator. MedChemesis facilitates the generation of close analogs of input molecules with improved affinity, bioavailability, as well as covering metabolic soft spots and finding optimal bioisosteric replacements. Now, let us find out how MedChemesis works within SeeSAR. Let's open SeeSAR 13. We see the golden touch of Midas shown in all its glory right here. Although our core motivation here is to learn about the usage of MedChemesis, let's take a moment to explore the revamped start screen of SeeSAR 13, which introduces two important modifications that enhance your experience and keep you up to date with the latest developments. First, we bid farewell to the traditional What's New slides on the start screen. Instead, we've introduced a direct link to the changelog, accessible through the new bullhorn icon located on the top right corner of SeeSAR. By clicking on the bullhorn icon, you'll be taken directly to the comprehensive changelog, where all changes and updates to SeeSAR are systematically documented on our website. This streamlined approach ensures that you have a centralized location to stay informed about what's new in SeeSAR. But that's not all. We've added a thoughtful touch to the bullhorn icon. It now features a notification dot, serving as a friendly reminder for two scenarios. The first scenario is when a new SeeSAR version is available. The notification dot will appear, signaling that an update is ready for you to explore and download. The next scenario is if you haven't clicked on this bullhorn icon to read the changelog even once. The notification dot gently reminds you to check the latest updates and discover the exciting enhancements we've made. Now that we are in SeeSAR in the proteins mode, let us download a protein structure with a bound molecule or a fragment to then use the magic of MedChemesis to generate analogs. For this purpose, we will use the protein with the PDB code 5HMZ. We see that the protein has a single bound ligand LNZ in this single chain protein. We will go ahead and extract this ligand by clicking on the radio button first to select the ligand for extraction, and then clicking on the green play button on top to confirm the extraction. Now, since we've really extracted the ligand from the protein, in the 3D panel you might notice that the ligand is missing from the protein. Do not worry now, since the ligand is still there in the 3D coordinate space of the binding site. To make it visible, we simply have to select the ligand from the table over here. There we have it. Our ligand looks great, with mostly all green Hydescorer, indicating that it's very happy in its bound situation. This could be a perfect example of a lead molecule starting off with very good binding affinity, presenting itself for further medicinal chemistry inspired optimization, or in other words, analog generation. To generate analogs for this molecule, we take this molecule to the Inspirator mode, which houses the MedChemesis functionality. We do this by right-clicking on the ligand in the table and choosing the option Add to Inspirator. With the molecule now in the Inspirator, we are able to visualize in a bit further detail that the molecule is very happy not only in terms of affinity, but also in terms of the torsion and clash quality. Now, the generation of analogs for this molecule using MedChemesis simply requires one click on this green button up top. Before clicking, let us take a closer look at the button itself. The symbolism on this icon is rather abstract on purpose, indicative of the analog signal from electronics that hopefully helps you make the mental connection with analogging that MedChemesis facilitates. We also see that the tooltip text on the icon explains the basic requirements for the analogging process to run, and that is a binding site and one or more molecules. We have satisfied these requirements, and we shall do one little adjustment to the run settings before we start. We go over to the Inspirator parameters button here and change the number of solutions from the default value of 10 to 100. Remember that MedChemesis can apply up to 290 medicinal chemistry inspired transformations to the input molecule to generate analogs, and hence we change this default value from 10 to 100 to see a larger variety of results. If you have several molecules in the table bound to the protein, then it would be wise to keep the number of solutions to a smaller value, say 10, to avoid being overwhelmed by the sheer number of results that MedChemesis applied to each molecule on the table will produce. Alright, so we've teased this button for way too long now, so let's go ahead and click it. Now that we've let MedChemesis generate a set of analogs and have also scored them, let us now take a few moments to analyze these results. First and foremost, we can sort the results based on the Hyde estimated affinity by simply clicking the header of the estimated affinity column. We find that MedChemesis has managed to produce at least 30 analogs with an improved estimated affinity compared to the input molecule. The input molecule in our case is in position number 31 as we see here. Now, in order to productively compare the different analogs generated with respect to the input molecule in 3D, we could first make the input molecule permanently visible in 3D by clicking this push pin button, and also by giving the input molecule a distinct color. Now, clicking through the different solutions in the table shows us in 3D the generated analog over the input molecule, and the applied transformation itself is shown with these orange capsules on them. The 2D panel down below also highlights the applied transformations with the orange highlighting. The next logical question we might have at this point is to learn which exact medicinal chemistry inspired transformation has been applied to a particular analog generated. This information is contained within the fragment origin column located over here. For example, here on the first result molecule, add_ethoxy indicates the addition of an ethoxy group to the position indicated on the molecule both in 2D and in 3D. Similarly, for molecule 2, a nitrile group has been added. A click on the header of the fragment origin column sorts the contents alphabetically, providing a rough means of grouping the different transformations applied to the input to generate the output analogs. Switching to the grid view on the table is another useful means to visualize multiple molecules in 2D along with the applied transformations. The generation of analogs with MedChemesis can be fine-tuned by using pharmacophore constraints to guide the analog generation. Let us see how this works with a simple example. Let us say that we want to make sure that this part of the ligand contains a halogen in the solution. We could go ahead and apply a pharmacophore constraint to guide MedChemesis to fulfill this condition like so. First, open the pharmacophore constraint dialog from the top toolbar. Click on Define New Constraint. Select an atom on the molecule around which the halogen constraint must be applied. Click on Set Sphere to Center, which centers the sphere around the selected atom. Select the constraint halogens from this drop-down menu. Click Apply, close the dialog, and run MedChemesis again. We notice that there are not as many results generated as before, but importantly, all generated results contain a halogen at the requested position. That brings us to the end of the MedChemesis section of the tutorial, and now we move on to something of a more visually impactful improvement in SeeSAR 13, which is to do with the ability to generate and control protein surfaces. The protein surface provides additional information beyond the secondary structure representation, offering insights into the global three-dimensional structure and the associated properties of the protein. So far in SeeSAR, the protein surface representation was restricted to the region around the binding site alone, but with version 13, we've extended this to the full protein. This not only helps in an improved understanding of the overall shape, spatial arrangement, and accessibility of the binding sites, but also helps you produce prettier pictures for your publications and presentations. To explore the full capacity of SeeSAR's protein surface visualization, we need a multi-chain protein. For this purpose, let us load the protein PDB structure 2FAX. We see that this protein contains 2 chains and 4 ligands, from which we will extract the ligand 1BN from chain B. Now click Apply and confirm it. Previously, the functionality to generate the surface of the binding site was found over here in the visualization settings, but this is not the case anymore. Since the protein surface is essentially a structural element, we have moved the action to trigger the surface display to the sequence view below. The latest addition in the sequence view toolbar, which reads Show or Hide Protein Surfaces, can be clicked to unveil the different options available within this setting. Now to show the surface of the protein, we click on the protein name, which starts the surface computation along with shadows. Now we see that the entire protein is colored white, except for the region around the extracted ligand, which is colored green to indicate the region of the binding site. This is the so-called standard coloring method in SeeSAR. 3 additional methods of coloring the surface are provided out of the box, namely the log-P based coloring method, which helps distinguish between hydrophobic and hydrophilic surfaces, the element-based coloring method, which distinguishes carbons, oxygen and nitrogen atoms on the surface, and finally the chain-based coloring, which is an easy means to identify the different chains in a multi-chain protein. We've probably noticed that all of these visualizations draw a beautiful surface on the protein, but are all opaque. We can change this by toggling the transparency of the surface using the transparent button right here. So it is not only possible to see the overall shape of the protein with the help of the surfaces, but get a view of the underlying secondary structure, as well as differentiate the 2 chains all at one go. Besides the presets that we've seen so far, we could add custom colors to the protein surface and the binding site like so. For this, we switch to the standard coloring method first, which brings us back to the white surface for the protein and the green surface for the binding site. Now, using the 2 buttons here, which are appropriately colored, we can change the color of the protein and the binding site to anything of our choice. A click on the protein button here opens the color palette, and a click on any of the colors here immediately generates a preview of this color applied to the protein. We can try a couple of different colors here and see how this works. Once we've decided on a particular color for our protein, we click OK to confirm. Now the protein surface has a custom color, but the binding site still has its initial default green. We can similarly change this as well. Now confirming the color will apply to the color of the binding site as well. Additionally, it is possible to apply the color of the binding site to the entire protein and vice versa. Clicking on this part of the button that says Use color for the whole protein transfers the currently applied color of this component to the rest of the protein. One of the consequences of SeeSAR's newest protein surface display capabilities is the fact that exploration of binding sites in the binding site mode is a lot more impactful. To explore this improvement, let us move to the binding site mode with the same protein from earlier, 2AFX. Now, we click on this button on top that triggers a search for unoccupied pockets on the protein surface. The predicted pockets are shown as these cottony clouds on the protein surface. This visualization per se is not new for SeeSAR, you've all seen it before. However, the presence of the protein surface visualization to complement the clouds enhances the understanding of the depth and accessibility of the pocket for a ligand from the surface. Now, turning off the surface visualization and turning it back on explains this at a greater extent visually than with words. In SeeSAR 13, we've expanded the capabilities of our 3D model export feature, empowering you to create captivating presentations in external tools like PowerPoint. Previously, exporting 3D models from SeeSAR was limited to molecules and the binding site residues and did not include protein surfaces or secondary structures. We've now improved this functionality to include full protein surfaces, including secondary structures, and all levels of transparency as part of this export. Let's have a look at an example of how this is done. Let's quickly create a little scene for ourselves to export. First, let's take the ligand from this protein from the protein mode to the Inspirator. Let us now generate 10 analogs, for example, for this fragment using MedChemesis. Now let's make these 10 molecules permanently visible in 3D. Let's change the color of the protein surface. And now from the Utilities menu up top, click on the Export 3D Scene button and save the .glb file with an identifiable name on your computer. Now open a PowerPoint presentation and insert this file as a 3D object. The entire 3D model as exported from SeeSAR is now available for us to play with in PowerPoint. Now feel free to add transitions and take your presentation to the next level. With this extended 3D model export functionality, you can seamlessly integrate SeeSAR generated protein structures into your presentations, capturing the attention of your audience and delivering impactful visualizations. With that, we've covered ground on the functional enhancements to SeeSAR 13, and now we move on to explore a list of convenience features that have been added to this version. We understand that efficiency is key when working with large molecule tables. And that's why we've implemented intuitive keyboard shortcuts applicable across all molecule tables. Let's take a look at these time-saving shortcuts that will streamline your workflow. To check a molecule on the table, simply use the combination Alt plus C. To mark a molecule as favorite, use the combination Alt plus F. And if you need to set a molecule as active or inactive, simply use Alt plus A. So all of these shortcuts can be used to toggle between the on and off states of a required functionality. So for example, pressing Alt and C together for the first time would check a molecule, and pressing that on the same molecule a second time will uncheck it. Similarly, pressing Alt plus F on a molecule in the table would first set it as favorite, and if it had already been set as favorite, it would remove the favorite tag from it. For the Alt plus A keyboard shortcut option, the action actually cycles between active, inactive, and to the reset neutral state. So this button has 3 states as opposed to the Alt C and Alt F options. We understand that flexibility is crucial when working with large sets of molecules. With the new enhancements, you can now effortlessly manage your input tables for the docking and similarity scanner calculations. The input tables now feature checkboxes, allowing you to selectively choose and delete those molecules that are not required for subsequent docking or 3D alignment calculations. This addition eliminates a previous bottleneck where all molecules in the input tables were automatically subjected to docking or 3D alignment calculations, even if they were not needed or not intended by the user. With this improved handling of inputs, you have the power to streamline your workflows, save time, and focus on the molecules that truly matter for your specific calculations. Moving on, we understand the importance of keeping track of checked molecules and ensuring their safety during your workflow. When you check molecules on any table, now an additional indicator will appear on the table header, clearly showing the number of molecules that have been currently checked. This visual cue keeps you informed at a glance, providing instant feedback on the number of checked molecules within the table. In modes that feature multiple tables, such as the docking and the similarity scanner mode, we've implemented a crucial warning system. If you attempt actions on checked molecules while molecules in multiple tables are checked, a warning will alert you. This prevents accidental deletion or movement of molecules that you may have checked in a different part of the table beyond the current view. With this enhancement, you can confidently work with your checked molecules, knowing that SeeSAR has your back, keeping your selection safe and secure. Stay in control and prevent accidental actions, ensuring the integrity of your work. We understand the importance of staying informed while working with SeeSAR. And therefore, in version 13, we've improved the way notifications are delivered, ensuring that you never miss critical information. The new notification system, there are 2 types of messages that you'll encounter. Infos, indicated by a blue background, and errors or warnings, either highlighted by a red or orange background depending on the severity. Errors and warnings remain on the screen until explicitly closed. This ensures that critical information requiring your attention is easily and readily accessible, implicitly urging you to take the corresponding action that's required. To provide a better overview now, there is an indication of the total number of messages available in the message center. Speaking of the message center, it is your central hub for managing notifications. You now have the option to either clear all infos or clear all messages within the message center. We hope that you benefit from the enhanced notification system with distinct message backgrounds, the ability to keep errors and warnings on screen until you're ready to dismiss them, and the convenience of managing your messages within the message center. Stay informed, stay organized. Convenient methods of filtering become extremely handy when exploring large datasets, and with that in mind, we've added 3 new combined filters within SeeSAR. You now have 3 additional options to refine your molecule selection based on well-known, well-established metrics, such as the drug likeness, which is based on the Lipinski's rule of 5, the lead likeness, and the fragment likeness. So these 3 options are found in the analyzer, and you can directly use them on all molecule sets. The exact combination of parameters used to create these combined filters are also shown in the details of the particular filter entry. And true to its name, these 3 filters present in the analyzer would greatly help you in your analysis processes, leading from large sets of molecules to narrowed down smaller sets that are filtered to satisfy those specific conditions that you're looking for. The final enhancement to the user interface of SeeSAR that we'd be discussing today also has to do with the analyzer itself. The Hydescorer definition file exports are also available from the analyzer and now include information of all active pharmacophore constraints to be used as post-processing filters for calculations with the external Hydescorer tool. Please note that this extended support of using pharmacophore constraints is only available from the analyzer and the docking mode, but not in the binding site mode, because you cannot set pharmacophore constraints within the binding site mode today. So there we are. We've actually come to the end of learning everything that we need to know hands-on and in terms of functional improvements for SeeSAR 13. Thank you for joining us in this journey through the exciting new features of SeeSAR 13.0 Midas. We appreciate your time and attention. We hope that the insights shared in this video have sparked your excitement and anticipation for the enhanced capabilities of SeeSAR 13. It is our mission to, besides providing you a cutting-edge tool, make the experience fast, visual, and easy, assisting you daily as you push the boundaries of drug discovery. We value your input and strive to continually improve SeeSAR to meet your needs. We encourage you to share your comments, feedback, and feature requests with us. And whether you're a seasoned researcher or a newcomer to the field, a newbie or a pro SeeSAR user, we're here to support your journey. Until next time, take care and goodbye.